In this recording, we're looking at section 8.4. 8.4 deals with number problems and consecutive integers. There are several different types of word problems. The majority of the word problems presented in this workbook are real-life application problems. Number problems are typically not based on real-life scenarios, but still require you to translate English words into algebraic equations and then solve them. Number problems are like riddles that use numbers and variables to describe relationships among expressions or a set of numbers. A specific type of number problem is a consecutive integer problem, which requires you to solve for a variable to determine several consecutive numbers that meet certain criteria. So consecutive integers have the form n plus 1, n plus 2, and so on, where n is an integer. So we're counting. N would be the first number, and it says at the bottom, notice that n is the smallest integer in the sequence, and then we're counting up. So n plus 1, n plus 2, for example, if n would be 10, n plus 1 would be 11, n plus 2 would be 10 plus 2 or 12. So it's a way of showing counting. If we have consecutive even or consecutive odd integers, we're counting by evens or counting by odds. And when you go from one number to the next in even or odds, notice you have to skip one. So 10, 12, 14, or 7, 9, 11. Either way, if you're counting by evens or counting odds, since you're doing every other one, the equation or the form changes to n plus 2, n plus 4, where n is an integer. So we can't count every one, we have to count every other one to be counting by evens or odds. So here's some things to look at. So we're going to determine if they're true or false and fix any false statements. And it says there may be more than one way to correct a statement. And so again, like saying it cannot be represented if it's false is just not a good way to fix it, which it would make it a true statement, but it doesn't really help us see what we're supposed to be doing. So we'll fix it better than that. The first one, odd integers 3, 5, and 7 can be represented by x, x plus 1, and x plus 3. So notice 1 and 3 are odd numbers as well. So let's check this. It's saying x equals 3. Well, x equals 3. They told us it's supposed to start with the smallest one. 3 is smaller than 5 and 7, so that's good so far. But if we do x plus 1, we are supposed to do 3 plus 1. And that does not give us 5, it gives us 4. So that's not going to work for us. And even if we took it a step farther and did x plus 3, we'll get 3 plus 3, which gives us 6. So that's not what we're supposed to be doing. And the problem is, even though we're counting by odds, odd numbers are still even apart because it's every other one. And so we're supposed to be using x plus 2 and x plus 4. That's the pattern we're supposed to use because 3 plus 2 is 5 and 3 plus 4 is 7. So again, this is false, even though we're counting odd integers, we still have to add multiples of 2 to get to the next odd number. The integers -5, -4, -3 can be represented by n, n plus 1, n plus 2, where n equals -3. So they're telling us that n instead of x this time, it doesn't matter which variable you use, but equals -3. Remember, that's supposed to be the smallest one, and it's not in this case. The smallest one is supposed to be -5. And if we tried to do this, then n plus 1 would equal -3 plus 1, which would actually equal -2. We would need to keep subtracting if we started with -3 to get even more negative, but that's not going to work for us. So the mistake here was that they started counting at the wrong number. Again, we're supposed to use the smallest number for our n, and so that should have been -5. For our last one, we have that we're counting evens. -2, 0, 2 can be represented by y, y plus 2, y plus 4, so even, and they're counting 2 and 4, which is good. And then -2 is the smallest, and -2 here is where it starts. We could even check that it is going to be a true statement because y is our smallest of -2, y plus 2 would equal -2 plus 2, which is 0. And then y plus 4 leaves us -2 plus 4, which is +2. Oops. I was trying to get ahead of myself here on my writing. So it should say +4 equals 2. So this one was true. And our middle one was false because they started again with the wrong number as their n. Okay, so those are the special number problems with consecutive integers, but there's going to be other number problems where we're not doing that. Here's an example of a consecutive integer problem. Notice it doesn't say consecutive odd or consecutive even. They're just 3 numbers in a row that have the sum of 21. So the pattern that we're supposed to be using, let's use n for our numbers, n plus 1, n plus 2. And we can stop there because we only need 3 numbers. So n is our first number, n plus 1 equals our second number, and n plus 2 equals our third number. Find the sum of the consecutive integers from part A and combine like terms. Sum means to add. So here's our first number. Our second number, I'm going to put it just in parentheses to show you that that's one number that we're going to find. And then our third number is n plus 2. And it told us to simplify by combining like terms. So again, we can ignore the parentheses. That's just to help us see that we have 3 numbers, 1, 2, and 3. But we have, remember, an invisible one here, here, and here. So when we add that, we actually have 3 n's all together. And then if we combine our plus 1 and plus 2, we have plus 3. So 3n plus 3 is the simplified form where we combine like terms. And now we're to write an equation with that using the fact that the answer or the sum has to equal to 24. So our 3n plus 3 needs to equal 24. So now let's solve it. So I'll bring it over here again. 3n plus 3 equals 24, spacing it up just a little to help me have room when I write. So when we solve this, remember we want n by itself. You always get rid of the adding or subtracting first. This 3 is being added, so we'll subtract it, which means we have to subtract 3 from the other side as well. And when we do that, 3 minus 3 is 0. So we'll bring down our 3n. Let's take all of that away. Just fix my n. So 3n, better looking n, equals 21. And now we get rid of our multiplication by dividing. So we'll divide the 3 off because 3 divided by 3 is 1. And 1n, we can drop the 1, make it invisible. And so 1n is the same as n. And then 21 divided by 3 is 7. So we found that n equals 7. But the questions are reminding us that we're not done. So n equals 7 just tells us what the first number is. So the first number, or you could say integer, in the pattern is 7. And so what are the 3 consecutive integers? Again, we're counting by ones. It was n, n plus 1, n plus 2. So we have 7, 8, and 9. And again, if we want to check it, we can add them all together. 7 plus 8 is 15. 15 plus 9 is 24. So it checks out. Okay, here are some problems for you to try. Notice number 5 does not have consecutive numbers. It's just finding one number, but you have to translate this. So here you would go through and translate. You've done translating before, but before you were doing expressions, not equations. The difference is expression is just like 2x minus 5, where an equation would be 2x minus 5 equals 13. And so you'll be creating your problem and solving it. Don't forget things like less than, changes the order, decreased by. Make sure you're noticing the difference. Less than switches the order, decreased by doesn't. And there's the equals here. So 5 less than a number actually would translate to n minus 5 if you're using n for your unknown number is equal to 13. Decreased by means we're subtracting from the 13, so we don't have to change the order there, the number, so that same number n. And then you would solve this problem to find out that your answer, your number is 9. But I'll let you do the steps for that and practice doing that. Again, the 7, make sure you notice things like we have consecutive even, and this one is just 3 consecutive integers. And so make sure that you're using the right pattern for those. Check your answers and the answer key if you're not sure what you're doing wrong. At this stage, you can still email me and ask for help. Otherwise, when you're ready, we'll move on to the story problems. A collect call from a landline in Ohio to another landline in Ohio has a connection fee of $2.75 and a charge of 36 cents per minute. Mr. Anderson made a collect call which cost the receiver of the call $9.95. This situation can be modeled by $9.95 equals $2.75 plus 36 cents M. So the unknown variable M in this case represents the number of minutes the call lasted. And it's nice that they used M to represent minutes. That's what I would have done. And so we're solving the equation. So again, they gave us, I'll put it up here, the equation of 995 equals 275 plus 0.36 M. So we need to work backwards. Again, we'll get rid of adding or subtracting first. The 0.36 is the one being multiplied. So we need to scoot over here to the 275. That's positive. So we have to subtract it to get rid of it. So 275 minus 275 becomes 0, like we want it to do. So we have to subtract 275 from the 995 as well. So when we do that, we get 7.20, or again, we can drop that 0 and just say 7.2. And then on this side, that's gone, and we're left with the 0.36 M. And so then we get rid of our multiplication by dividing. So we're going to divide both sides by 0.36. And so when we do that, we see that M equals 20. And so what this means is the phone call lasted 20 minutes. Let's take a look at another example. Robin is in charge of purchasing desserts for a dinner party that her nonprofit organization is throwing. She decides to buy a cake and several specialty cupcakes from Barbara's Bombastic Bakery. She needs to buy one 8-inch round cake, which costs $19.50. She has $45 to spend and will spend the leftover amount on cupcakes, which are $8.50 a box, and there's 4 in a box. How many boxes of cupcakes can Robin purchase? Okay, there's a lot of numbers being thrown in here. Let's take a look at this for a second. So she needs to buy one 8-inch round cake. So that 8-inch is just describing the cake. We don't need that for any number in the problem. We just need to know that there was one of them. And then it tells us that the $8.50 is for a box. And it does tell us how many are in a box, but it's not asking us how many cupcakes can she afford to buy. It's asking us how many boxes of cupcakes can she afford to buy. So that number is not important to solving the problem either. So that eliminates those numbers that are in there that are just descriptors to help paint this picture, but not important to the actual math of the problem. So what is the unknown value? That's our question. Our question is how many boxes of cupcakes can Robin purchase? So the unknown is the number of boxes. And it tells us to use C for that. I would use B for boxes, but they're using C, which represents the boxes of cupcakes. And so if we set up an equation, I'll just put it over here because we're going to solve it so we can just work from it there. So it says she has $45 to spend. So let's put that first. And we know the cake is going to cost $19.50. That's not changing. But what changes is how many boxes that she can buy. And each one of them costs $8.50. So we'll do plus $8.50 per box, so times C. And if you did like 8.50C plus 1950 equals 45, that's fine. Normally for myself, I like to do, again, the variable, I've mentioned that before, the 850C plus 1950. But just the way the story problem reads, it makes more sense. And hopefully you could follow along with setting it up this way. But again, as long as the 45 is on one side, the $8.50 is the one being multiplied to C, and it's an addition on that side with the 1950. In whatever side or way you put that, you will still be fine, as long as you do the math to get C by itself. So to solve the equation, we need to get rid of the 1950 first on the right-hand side. Again, you're always getting rid of adding or subtracting first. And so we have to subtract the 1950 from the 45 as well. So 45 minus 1950 leaves us with 2550. And then the 1950 minus 1950 zeros out. So that leaves us with the 850C on the right-hand side. And so now we need to get rid of that multiplication by dividing 850. And so C is left by itself on the right, and 2550 divided by 850 is 3. And so what does that mean? What our answer means is that that 3 represented a number of the boxes of cupcakes. So Robin can afford to buy 3 boxes of cupcakes. Last story problem. For his Super Bowl party, John bought 3 large pizzas, a pepperoni, a sausage, and mushroom, and Hawaiian pizza with ham and pineapple. Each pizza was cut into the same number of slices. After the party was over, there was 1/4 of the pepperoni pizza, 1/2 of the sausage and mushroom pizza, and then 3/8 of the Hawaiian pizza left. There were a total of 9 pieces of pizza left over. How many slices was each pizza cut into? That sounds like a very confusing problem, I know, but let's look through this problem step by step. The unknown, again, let's look to the question, how many slices was each pizza cut into? And so the number of slices per pizza. And it says let P represent this. And again, I would probably use S because S is slices, but they're using P for pizza, but that doesn't matter. That's just me being nitpicky. One thing you need to remember for this problem is that no matter the toppings, and we're not being charged for topping and stuff like other questions, but the size of the pizzas are the same size. And so when we're plugging this in, we're going to have the problem set up with thinking that it's not a pepperoni pizza, it's not a sausage and mushroom, it's not a Hawaiian, it's just different pizzas. And so we have 1/4 of one of the pizzas left. So 1/4 of the number of slices in that pizza would be 1/4 times P. We also have, so we're adding to it 1/2 of our second pizza's slices left, which again, we don't know how many slices are in pizza, so that's P. And then finally, we have 3/8 of our third pizza left, and 3/8 of the number of slices there would be 3/8 of P. We don't know what P is yet, but we know how many slices that adds up to, and it says that there was a total of 9 pieces of pizza left. And so that total equals 9. And so it asks us to solve the equation in this problem. So there's a couple different ways that you can do this. First, you could multiply everything by the least common denominator, which in this case would be 8, to get rid of fractions. Or you could look at getting common denominator and just adding them up that way. And that's what I'm going to do, is just to rewrite it. And so since 8 would be that common denominator, I have 1/4. And so in order to get the 4 into 8, I need to double it. So let me show that over here. 1/4. I need to be an 1/8. And so I need to do 4 times 2, or doubling. So I have to do 1 times 2 there, which will give me 2/8. We can do the same thing with the 1/2. We have 1/2. We need it to go into 8ths. So in order to turn 2 into 8, we're multiplying by 4. Got ahead of myself there a little bit. And so 1 times 4 would give me 4/8. And then the 3/8 is already in 3/8. So I'm just going to show that. And again, the calculator, you could just do 1/4 plus 1/2 plus 3/8, and it would give you the total there. But I'm showing that for my steps, I'm going to have it as 2/8 P plus 4/8 P plus 3/8 P equals 9. And when I add those all up, 2 plus 4 is 6, 6 plus 3 is 9. So 9/8 P equals 9. Now for this, our multiplication is of a fraction, but that's okay. we can still divide by what's being multiplied, dividing both sides by 9/8. And again, you can rely on your calculator for that. And you can do 9 divided by 9/8. Dividing by a fraction, another way to think of that is multiplying by the reciprocal, which is what you end up doing, even if you're letting the calculator do it and you don't know it. So I'm going to show that here by multiplying by 9/8. So I can see that my 8's cancel, my 9's cancel over there, and I'm left with P. Here we have, if you want to put this as a fraction, hold on a second, I made a mistake. I wrote 8/9 over on that side, the left side, but when I moved it over here, I had a moment where I flipped it back when I shouldn't have. So I'm multiplying by 8/9. So we can think of this as over 1, which means our 9's will cancel, and I'm just left with 8 over 1, which is 8. Or we can think 9 times 8 is 72, so it would be 72 over 9, which would give us 8 as well. So what this means is that each pizza is divided into 8 slices. And if we wanted to, we could do 1/4 times 8 plus 1/2 times 8 plus 3/8 times 8 to make sure we could get that 9 if we weren't sure if our answer was right. So this one is a little bit more tricky, but again, if you have a problem similar to this on your homework and you're stuck, you're not sure how to solve it, send me a screenshot and I'd be more than happy to walk you through it. Otherwise, I'll see you next time.